was kind of nice. It was warm, right? It was nice. So I thought that was good. Did anybody's team win? Not yours. Not yours. So I don't know. I didn't watch the game. But I did think it was a nice weekend. Okay. What does this look like? It looks like a LAN, right? Okay. And what does it cause you to think of? So we know it's a LAN, right? Yeah, it is a topology. We've seen something like this before that we've done. Oh, yeah, that's a good catch, right? That's a good catch. So this has been assigned an IP address of a .254. Normally, the rule of thumb is that you give it the first usable address, but it doesn't have to be. That's just what most companies do. And actually, your home network, what did you see that your default gateway was at your home? It was a 1, right? It was the first usable, okay? So where have we seen this before? We just said one place. What? Oh, the lab on last week, the lab on Wednesday, right? We built this lab. Now, we didn't set it up with 4 different end devices. We just don't have enough space. You set up a router, you connected it to a switch, and then you connected an end device, right? So this is the lab that we did last week on Wednesday. And then also we have a setup like this at our houses, right? I mean, unless you've set up VLANs, you probably have just a simple LAN at your house, okay? So when we talk about LANs, what we're talking about is something called a broadcast domain. Okay, a broadcast domain. What determines the starting point of the broadcast domain? Okay, so think about that question. You've read about a broadcast domain. I think in this module we've, broadly talked about it. Okay, so first of all, let's start with what is a broadcast? Yeah, so it is when we send a message to all of the devices on the network. Okay, so if we were on one network in here and all of you received the message, that's a broadcast. And addressing wise, it's an address where all of the host bits are turned on. Write that down. Okay, a broadcast is when all of the host bits are turned on. So either write it down, add it to your mind map, capture that information. Yeah, it's when all the host bits are on. The broadcast address is when all the host bits are on. The network address is when all of the host bits are what? They're off. Yeah, they're all turned off. Yep, all the zeros are off, right? So the network is you have the network bits and all the hosts are off, but with a broadcast, all the hosts are on. 1111111. Okay. All right. Now we have said that there are 3 things that identify or describe the default gateway. Okay. So Getsamani, can you give me one of them? What describes the 3 things that describe the default gateway? Give me one. Okay. The entry and exit point of what? Okay, everyone turn off your monitors just for a second. I'm sorry. I know I told you to take notes, but I want you to turn off your monitors. I just want to see what you know, okay? Just want to see what you know. We've been talking about a default gateway a lot already. Okay, so you're right. It's the exit and the entry point for the what? The LAN. The LAN. Okay, now I'm going to actually make that number 3, okay? I know that that's probably the easiest one to remember because that's the first thing that everyone always says, but I kind of think of it as the last thing. So it's the exit and the entry point for the LAN. And basically it's for the traffic of the LAN, right? If this host device needs to send traffic over here to another network, it's got to go up through this interface in order to get out. Okay. Nicola, what's one of the others?
Normally this function would be the router.
Okay. What specifically about the router?
That acts as a default gateway because it allows you to move the data to the other network.
So this whole router is the default gateway?
Yes, that normally.
So what about this interface on the router that's connected to a WAN? Is that a default gateway? This interface? No, it's not. We talked about that. Okay, Joe, give me another one. Okay, the interface on the what? Right. Okay, so a default gateway is an interface on the router. It's not the whole router. Okay, that's really an important detail. It's the interface on the router. If you say default gateway, I am going to think about, oh, that's an interface on the router. It's not the entire router. This interface right here that connects to another router is not a default gateway. Okay, so it is the interface on the router that faces the what, Joe? It faces the LAN. Okay, it faces the LAN. This is not a default gateway. This is facing a WAN. It's just a regular interface. Okay, that's an important distinction. Okay, you said the last thing, Joe. I'll take it from you. What is it? Okay, from the network that it faces, right? Yeah. So it's going to have an IP address, right, on the interface. And that IP address comes from the local area network. It comes from the local area network address, from the local network. Okay? All right, I want everyone to figure out what is the network address. Just figure it out and keep it to yourself for a second. What's the network address for that LAN that you're looking at up there? Okay, once you've got it, just pop your hand up so I can see that you've got it. Okay. All right, Derek, what is it? Okay, so the network address, okay, now the network, it's important that we designate where that network starts. It starts right here, okay, and it's going to encompass the devices that's part of it. It doesn't encompass this interface. This is going to have its own network address. It's going to have its own network address, okay? Now, this is going to have a network address, and we said that it was 192.168, did you say 10.0? And what's the subnet mask? /24, okay? This network address takes care of all of these devices. It's kind of like the umbrella, or in the videos it talks about it kind of like like a zip code, like it takes care of everything. Okay? Normally, not always, we would give it the first usable address for the default gateway. Derek? I'm so glad you asked that question. Okay, that's a really good question, and I'm seeing this a lot. Okay, so the question is, do I have to put the /24, right? Like, could I have just written it like this? 192.168.10.0, right? Okay, so what are some of your thoughts about that? Austin? Yeah, like, couldn't this be a /23? Right? It could be. It's important that you always include the slash notation or the subnet mask written out, because otherwise it could be anything. You know, if I give you 192.168.0.0 and I'm like, okay, what's the first usable address, or what's the 15th usable address? Well, who knows, because it could be a /24, it could be a /19, it could be a /16. So it's always important to include the slash notation or the subnet mask always. And you'll see in any of the quizzes, you'll always be asked to give one or the other. One or the other. And the rule of thumb, and this is the same in the industry, is if you're asked for the subnet mask, that means they want the decimal, 255.255.255.0. If it doesn't say subnet mask specifically, then you would give the slash notation. So if they say, hey, what's the network address? Then you would want to be like, oh, 192.168.10.0/23. If you see it where it says, what's the network and the subnet mask? Then usually what they want is 192.168.10.0, 255.255.255.0, right? That's the difference. And a lot of times in the quizzes, you're going to see where it'll give you an example. Like, you must include the slash notation. If you don't see that, then the question's usually going to ask you for the subnet mask. And that is true of every single answer, like every single address. You wouldn't provide the slash notation on just the network address. You'd put it on the first one, the second one, the last one, the broadcast. Just always include it. It's safer that way, right? It's just you're less likely to make mistakes when you're assigning IP addresses. Okay. All right, so we see here that it is an interface on the router that faces the LAN. This term does not apply to a WAN. It has an IP address on it that would come from the network address, right? Comes from the network address. In this case, we're using the last usable address. And it is the exit and the entry point for data that's coming and going. All right, what was my first question? No, before that started this conversation even, I think. Or maybe after the question, I don't know, but somewhere in there. Okay, what does this look like? So we said it looks like a LAN from the lab and your home. Okay, and then we diagnosed and broke down what a default gateway is. Then the question is, it was something like this: what's a broadcast domain, or where is a broadcast domain? Right? Remember, we were talking about a broadcast domain. Okay, so close your monitors. Okay. I just want you to think about this. Based on what we've talked about in the last 10 minutes, what might a broadcast domain be? Joel, what do you got? Yeah, exactly. That's exactly right. So the broadcast domain, say that again. You actually said it better. Really good.
So basically, broadcast domain is all the devices on the same network
Yeah.
receive one message from a singular source.
Exactly. Exactly. They can only receive it because they're sharing the same network. A broadcast domain starts, where does it start? Where does a broadcast domain start? So based on Joel's answer, go ahead. What determines where it would be? The default gateway. The default gateway, the network, right? So this interface, the default gateway, is more or less the starting point of the broadcast domain. Every device on here would receive the broadcast message that's within this network. Would this interface over here receive a broadcast message from this network? No, it wouldn't. Okay? Not only that, WANs don't broadcast. WANs don't broadcast. Okay? Everybody got that? So this is our broadcast domain. This is our broadcast domain. Yeah, this whole LAN, yeah. So the default gateway is more or less the starting point. With this designates that anything here is part of the broadcast domain. Okay, anything there is part of the broadcast domain. Okay. Now, why, based on what you've been reading, like, why is that important? Yes? Yeah. It would not. Okay, let's break that down. That's a really good question. Okay, I want you to think about the lab that we did on Wednesday. Okay, on the lab that we did Wednesday, we assigned the default gateway and IP address, right? And then we had a host. We assigned that an IP address. And I think we even assigned, if I remember correctly, I think we assigned our switch an address, so I'll just give it a 15, okay? So, would the switch hear the broadcast message if a broadcast went out? It would, right? Would this PC hear the broadcast? It would. Okay, now, out of band. We had a console connection set up so that we could console in through the console port, right? Con 0. And then I could also console into this, right? Through the console port, con 0. What address did this PC have? Well, like, give me, what did it start with? 172. Totally different. 172, whatever it was, 200, I don't even know, 16.27, and I think we have a 23. Don't we have a 23? Can do a, oh, never mind, don't do it because I have your computers off. Just a minute. I will do it. CMD. I think we'll see it. Yeah, so the 172.23.176 something. We, and it's, what is that? 255.255.240? That's a slash what? Huh? It's not a 23. What is it, Cody? 20. It's a 20. Okay. So, does that answer your question, Derek? Would that be would they hear the broadcast domain? The broadcast message? They wouldn't. They're a totally different address. It can't hear the broadcast domain. It can't hear the broadcast that goes to the broadcast domain. Okay? Nope. It can't hear it. It can't hear it. Okay. Now, what I want to do, again, leaving your monitors off. Okay. I'll start with you, Gianni. We're going to give me the OSI model. What's layer number 7? The one above it. All people seem to need data processing. Okay. Application. Okay, and I'm going to take your number 6, okay, presentation. Let's see, 765, Rob, layer 5, session. And Joe, you've given me an answer, Nicolo. Number 4. Transport. Tie. Network. Joel, you gave me a good answer. George. Data link. Jonathan, number 1. Physical. Okay. Physical. All right. All people seem to need data processing, okay? So again, one of the things you want to think about is like, how do all these things link together, right? How do these things all come together so that it starts to make sense? Let's do the PDUs, okay? Austin, the PDU for application presentation session? No? Don't send pets for beer? Or do send pets for beer? Cody, the transport? Okay, segment. Jonathan? The network layer PDU? It's not the frame. It's not bits. There's only one left. The network PDU. Don't help him. He knows it. Don't send pets for beer. Okay. Get some money. Data link. Frame. Derek. Okay, bits. All right. And module 6 is about the data link layer, right? Okay, the data link layer. And what device did we say mostly functions at the data link layer? The switch, right? So for the most part, the switch functions at the data link layer. We got that? Okay. Okay. Yes. Yeah. 100%. Yeah, 100%. And that's where I'm going with this. Okay. Now you can turn your monitors back on. Okay. That stuff we just went over, I shouldn't have to go over it ever again. Ever again. When I come in here and I say, what are the 3 things that define a default gateway? Every one of you should be raising your hand like, oh my gosh, I know. Okay? It should not have to be a conversation. Same goes with the application presentation session, transport network, data link, physical layer. Okay? Okay. Austin brought up the NIC card, right? So these computers have a NIC card in them. So when this is plugged in, the NIC card functions at the physical layer, but it's also got a layer 2 job. So it's got a layer 1 job and a layer 2 job. Oh, I just heard something about an application layer data breach. I was trying to think. I was going to bring it up. I can't remember what it was. Anyway, there was a big application layer data breach. Okay? So when this is plugged in, right, it's doing stuff at the layer 1 and the layer 2, the NIC card. And even our, every port that is on our switch, because we see there's like 24 ports, right? Those ports, they are functioning at layer 1. The actual physical port that you're plugging in, that's layer 1. That's layer 1, okay? But the switch and the processing that it does is layer 2. What's one of the main jobs of layer 2? There's a bunch of them, but what's that? It does. So it does some frame checking, right? FCS. It does a little bit of error detection. So let's see. We're gonna start doing this for error detection. So it does some error detection, and it uses the frame to do that, right? It counts the number of bits. Okay. What else does the switch do and layer 2 do? Derek, you had another one? Not exactly. It doesn't determine the data. It doesn't even know what the data is. A frame doesn't know what's inside the data. So you might be thinking of something else. Austin? That's really at layer 1. Okay? De-encoding and encoding are at layer 1. What is the job? What's one of the main jobs of the switch at layer 2? What's one of the main jobs of the switch? What is it? Did you say routing? It's not routing, because routing would happen at the router. Router. Okay, Ty.
It connects the upper layers to the physical.
Okay, more basic than that.
More basic.
So like for a switch, right, switches basically they allow other devices to basically port into one thing.
Okay.
Like when you're wiring, you can wire different formations and stuff.
Okay, I'm going to reword that. It connects devices on the same network to each other, right? It connects devices on the same network to each other. And Ty, you're right. It can connect to the upper layer, but can I connect a switch to another switch?
Actually, yes.
Yeah, of course I can. I can connect a switch to a switch. So is that connecting it to an upper layer? No. A switch to a switch is all at layer 2. So if I connect another switch here, that's just a 2 to a 2. You're right, it can connect it to an upper layer device, but I could connect 48 switches if I wanted to. Okay? Gianni, what does a switch do? It might, but what if I just connect it to another switch? Then it's not connected to a router at all. Okay, so I don't think you're going to find the answer that I'm looking for in the book necessarily. This is going to cause you to think about what you read and what you learned and what we've been talking about. Actually, the book does say it exactly clearly. Austin? No. I mean, yes, but no, that's not the answer I'm looking for. Yes. Okay. That's not what I'm looking for.
Which question are you looking for now?
Okay. So this switch functions at what layer? 2. This switch has a job. And we've talked about a lot of things. It connects the devices, right? But at its very core, it does something inside of this switch that allows it to do all the things that you've all just mentioned. Okay, that allows it to connect these together, because can this PC talk to this PC? It can, right? It can talk like this, right? But there's something happening in the switch that allows that to happen. What is the switch doing? What? Yes. What's it doing with the MAC address?
It uses it as an identifier.
Okay, so does it keep track of MAC addresses? Okay, and what layer do MAC addresses function at?
In the same layer as the switch.
Yeah. Okay, so at the very basic understanding, a switch keeps track of MAC addresses. Okay? It keeps track of MAC addresses in what? What kind of a table? A MAC address table. Okay. Now, why does it need to keep track of MAC addresses inside the MAC address table? Why does it need to do that? And that's going to come back to some of the answers that you've been saying. Joel? Yeah, you're on the right track, Austin. Okay, but if it uses MAC addresses, does it have to know the IP? No, it doesn't. Okay, so again, just think about this at the very, like the basics, right? What is the PDU at the data link layer? A frame, okay? And what's inside of the frame? One of the things, there's a bunch of things, but what's one of the things? MAC addresses. Okay, MAC addresses are inside the frame. Okay, so just at the core level, what the switch is doing, it's keeping track of these MAC addresses so that it can move frames, right? It can move the frames between the devices. Okay, so I'm just trying to break it down at like its basic levels and the different terminologies that's going to apply to the switches. Okay, so the switch is going to build a MAC address table. It's going to keep track of the MAC addresses and the ports so that it can move the frames around in its domain. Okay. Now I want to talk about the router for a minute. And the router is the what layer? Layer 3, which is what layer? The network layer. The network layer. Okay. Does a router perform any layer 2 functions? And before you answer, just think about it and look at the topology. Okay, this one up here. So we've got this connected, right? So we've got this WAN. Okay, so hold on, Austin. So what do you think the answer is? Okay. So someone tell me why. Hold your thought, okay? So you're right. The router has some layer 2 functionality. Why? Hold on, Joel. So I'd like someone to answer that hasn't been answering. Okay? Just because I want to spread the wealth. I want everyone to have an opportunity. Hold on, Joe. So we know Derek gave us the answer, yes. Okay, so it does. So the question is, does a router have a layer 2 function? The answer is yes. So like, what is that based on? Why is the answer yes? Rob, what do you got?
Communication, because, like, extended communication,
Yeah, they are communicating.
they communicate via the default gateway, because that switch has to talk to the router somehow, and the router has to talk to the switch somehow.
Okay, you're right about that. What about these two, router to router? Okay, so they have to communicate. That's true, right? So if we think about the fact that a router is connected to a router, but we all just agreed a router functions at layer 3, what part of the router is functioning at layer 2? Think about, don't think about the data, think about something physical. Okay. Hold on. Derek, when you said yes, what were you thinking?
Well, I was thinking because you said the switch is pushing data from device to device, the router doing that, going through the default gateway, pushing it to different data, push to different LANs or WANs or whatever that may be.
Okay, so Austin, what do you got? The NIC card. Okay, it's a simplify it, okay? In order to connect this router to this router, I have this cable. Now on a router, we actually call this a WIC card. And a WIC card, okay? Is cable functioning at what layer? Layer 1, physical. And when you plug these cables in, they've got to plug into a WIC or a NIC card. What layer does that function at? 1 and 2. Where was that? 1 and 2. 1 and 2. Okay. The reason this is important is because those can be tricky questions and tricky conversations about what layer does a router function at. What I want you to think about when you're thinking about layer 3 and the routing, a router, is it thinks. Like a router has more of a thought process, and it functions at kind of like a smarter level than a switch. The switch is building this MAC address table so that it can move the frames. A router makes routing decisions. It has logic. It has logic inside the router. That's what makes it a layer 3 device, is that it has logic. Now, once it moves the packet or the frame to the interface right here, and it's got to move the data across, it's still just a layer 2 function. It's a layer 2 function, okay? That's an important distinction to understand, all right? That's an important distinction because this WIC card or interface, it still needs to look at the media and determine what kind of media is it. And that's happening between 1 and 2. Like, is this fiber optic? Is this electricity? Is this wireless? And that's all a layer 2 and a layer 1 function, okay? If logic is involved, a decision about where to route a packet, that is the brain in the router thinking about it, okay? Thinking about it. Okay. Questions about all that? Okay. All right, let's take a break. It's 1:40, it's 1:50, come back at 1:58. Yes. About this or? Okay.
More so the feedback saying that might enough.
Mm.
Something like this would be better. I don't know if the notes are coming from you or not.
Some of them are, some of them come from a grader. There's 3 teachers, and we all work on grading together, so. It looks better. It looks better. So, you know what? I'm going to bring that up when everyone comes back because I actually want to talk about that. People aren't, in general, doing enough. Too vague. I can't tell if you know. You know, a good way to think about it is if you gave this to a person that doesn't know anything about the data link layer, would they be able to read this and walk away with some understanding? Not the same understanding as the book. Like, we're never going to be as good as the book. But could I be like, oh, okay, so there's this thing called the data link layer, and there's an OSI model, and it's at a switch, and it does this and this. Like, think of it like that. But I'm going to bring that up because you're not the only one struggling. And we see this every semester. It takes a while to kind of, get in the groove of a mind map. Teaching it. Honestly, they should be paying us for that. It needs to be the reverse. Yeah. Well, when AI takes over too many jobs, like, we need a way to make money, and that will be it, to sell our data. But they're already going to own it all. It's really frustrating.
That's why my dad is looking for ways to basically cut his data off from like corporate supply lines.
Yes.
Be in charge of his own data.
Yes.
Able to, like, if he wishes to sell his data.
Yeah.
Pay for his data.
And really, like, if we had known that this is where it was going, like 30 years ago, we would already have had protections in place where we own our data so we could sell it. If Target wants to target me, then you can buy my data and you can pay me yeah, I agree. Okay, so how many LANs do we see up there, right? Just count them, keep it to yourself, just count them up. How many LANs do we have up there? Just keep it just quiet. Okay, everybody got how many LANs they see? Okay, with your hands up and fingers, how many LANs are up there? How many LANs? Okay, so I see five. Yeah. Okay, I see 5. So how many default gateways are there? How many, if we see 5 LANs, how many default gateways are there? There's 5, right? There's 5. Okay. Now, I want to make a distinction that's important when you're doing topologies, okay? And we're going to be working with topologies. Like, I want to tie back, like, the different layers to where we're at in the topologies, right? So we've talked about layer 1. We know that the NIC cards, we know that the ports, those are layer 1. We also know that they have a layer 2 function, right? We know that they have a layer 2 function. And then we know that right here, this is a default gateway. It has a layer 1 and a layer 2 function. The router, its logical brain is where layer 3 is, the network layer, okay? Now, how many WANs do you see? Again, just count them up. And then let's have a show of fingers. How many WANs do we see? How many WANs? Okay, so I see a 1. Joel, why do you see 2 WANs? There's one on the right, and then there's one on the left. Let's see. Oh, now that I'm looking at this again, we have 1 WAN. We have 1 WAN, right? So I've got an interface right here, and this goes up to the internet. Somewhere in here, I've got to have a router. So this is a WAN. This is a WAN. Okay, so we've got 1 WAN. Now, this might be a company, right? This might be a business. So, like, my favorite business to reference is Petopia, right? So I might have this business called Petopia. And over here, I have a web server, an email server, and a file server. So maybe I have, like, my point of sales information in here, you know, what prices. I've got customer records, right? There could be, who knows what's inside that file server, and then email and web server. Over here, right, I might have like pet food store. I might have a pet food store that's on one network. And then I might have like vet offices, right here. And then I might have, what else? Veterinarian. Oh, I already said vet offices. Groomers. And then over here, I might have like my headquarters, right? Where it's just a small little company and it's me in my house. Yes. It could be, it depends how you set it up, but not necessarily. It would depend what you overlay it with as far as the cloud goes. Yeah. Okay. I want you to just notice something about these addresses because we're going to be talking about this today, okay? Do you see how this is 100 and /24 because they left that off? And then we've got 101/24, that's the next network address. And then we've got 102, that's the next network address. Now here, if we give this an IP address, this might be like 192.168.100.4, and maybe I've got a couple more PCs, and that's a .5, a .6. Does everybody see that? So this one might be 192.168.101.10/24.11/24.12, but they belong to this network. Does everybody see that? Like, just like your home, right? You have a default gateway, and then you might have your computer on your network. You have your cell phone on your network. You might have a printer. You might have your air, like my air conditioning thing, my Ring camera, like all that attaches to my network, but they have their own IP address, but they belong to a network. Okay, now here's a distinction that I want to make. When you are doing a topology, in this class and we ask you to circle the networks, okay, is the default gateway part of this network? Yes. Is this default gateway part of this network? Yes, okay. It's important that if you're actually identifying it through labeling, like circling, you always want to include your default gateway, okay? It's just the appropriate way to do it. It's just the right way to do it, okay? So that there's no confusion that this default gateway goes to this network, okay? So when we do challenges in here, we have times when we're circling networks. Be deliberate, right? Be detailed about what's part of your network. When you're working with customers or when you're working with other technical professionals, it's important that you are diagramming things properly, okay? Need to make a note to myself. Mind maps. Okay. How many broadcast domains do we have up there? Okay, show of fingers. How many broadcast domains? Yeah. Okay. What determines the start of a broadcast domain? The default gateway. How many default gateways do we have? 5. Okay, so we have 5 broadcast domains. Remember, everything on here, they would receive, if a broadcast message went out, everything on this network would receive the broadcast. And that includes the default gateway. It gets the broadcast message too. It's part of that network. Okay, we have 5 LANs, we have 5 broadcast domains. Are links between routers broadcast domains? No. Routers don't broadcast to other routers, okay? Routers don't broadcast to other routers. They just don't do it. Yeah. Just LANs. Just LANs. No, it would be its own domain. So a VLAN, which is a 150 subject, so understanding all of this is really important as you begin to advance your knowledge because VLANs are more common, right? But if we don't even understand what a LAN is, knowing how a VLAN works is like, huh? Yeah, but a VLAN is its own LAN. It's just that it's virtual, so it would receive its own broadcast. Yeah, good question. On a switch, all ports belong to what VLAN? Right? VLAN 1. On a switch, all ports belong to VLAN 1. All right, I just want to review a little bit from last week. And also, before I move on, I want to talk to you about your mind maps. So with mind maps, first of all, we don't grade them like the day, like Monday, right? Because they're due on Monday at noon. So I want you to get most of your mind map turned in by Monday at noon, okay? And we are going to look at them because I want you to have a chance to learn something today, you know, on Mondays. And if you have something to add to your mind map, you can add to your mind map, okay? And then that way it helps you beef them up, all right? This mind maps are graded on the breadth of the module and the depth, okay? What I'm looking for is that you are engaged with the material and you're learning something such that you can put it in the mind map, and you could have a conversation about it. You could share some information that lets me know that, oh, they're kind of getting it. Oh, but I have to clear this up because I can see that there's some issues with this. Not everybody's understanding this. Okay. Module 1, we just used that as an example. Module 2 was a really short module, and it was mostly about commands. Okay, so you wouldn't have had a big mind map. Module 3 was giant. Not only was it giant, we talked about how important it was, right? So you want to make sure that your mind map reflects the content of of what you're reading. Module 4, not quite as big as Module 3, but big. And I'm not saying because a module's big, you have to have a mind map like this. Okay, but I need to be able to tell that you're engaged with the material. And one way I think to think about it is, how good did the mind map help you when you did your proficiency check, right? Did you have enough information in there? The other thing is, can you explain a topic to somebody in a way that they can understand it? One of the things that I work really hard at is being able to explain something in a more simplified way than the book does, okay? And that's one way you can gauge about your mind map is, would I be able to explain what layer 2 is, the data link layer? Look, I know that it's something on the OSI model. Switches function at layer 2. Switches keep track of MAC address tables. If you gave your mind map to someone who's maybe interested in IT but doesn't know anything, would they be able to look at your mind map and be like, okay, I think I'm getting it. I kind of get that. You're not giving them the book, right? They're not reading the book, but you're giving them a high level overview. So that's a good way to think about it. Also, you can resubmit mind maps, okay? So if you got a low score and you went in there and you're like, okay, you read the feedback and you want to beef it up. Just send it, resubmit it. We will look at it again, okay? I'm happy to look at it again. We don't expect you to be networking geniuses in week 5, and I don't expect you to be a mind mapping genius in week 5, okay? It takes a little finesse. The other thing to think about is, whatever IT field you go into, you are going to be expected and required to be able to manage several different software platforms and collaborative platforms, right? Not necessarily mind map, especially not this free one that's not amazing, right? This is a free one. There are much better mind mapping platforms, but mind mapping is fairly common in the IT world. Okay, so that's one of the reasons we picked mind mapping. Again, they usually, a lot of times Lucid Charts is used. Also, there's topology software. So one reason, again, I want you to think about your mind maps is just if I had to use a software that I was unfamiliar with, or I had to teach somebody how to use it, right? Could you do that? So this is really just to keep you moving in the direction of developing the skills that you need in a job. Okay, whether it's an IT job, an engineering job, wherever you might be headed. Okay, so if you didn't get a good score on your mind map and you want to resubmit it. It's totally fine with us, okay? And if you have a question about it, then ask. The other thing I will tell you is, if you're just copying from the book, what that tells me is that you do not take time, you're not reading the book. It tells me that you're copying and pasting. So I'm going to assume that if you copy and paste everything, now again, sometimes it's okay to copy and paste, right? This definition is the best way to say it. This picture from the book, it really gets it across. But if you copy and paste everything, which I'm seeing a lot of, the first thing I think is, this person did not read the book. This person doesn't understand anything, and all they're doing is copying and pasting to check off a box. Okay, literally, anywhere from 3 to 5 hours would be spent reading and building your mind map, okay? If you do a good job with your mind map and your reading, all the other assignments are easier. The conversation in here is easier. When I ask you to, have to come up with something, that isn't word for word from the book, like you could actually think through some of those things because you've read the book, right? Or you've watched a video. And the other thing is, I don't know, has anyone watched one of my like module reviews? Okay, those are good too. You know, you can use the module. I don't have a module review for every module. But like if you want to look at and watch that whole module review instead of reading the book, again, it's not as good because I'm catching the high level stuff, but it's still good. It's still good, right? I think I had one for Module 4. I think I had a full module review for Module 4. Module 3, I have a really good video about the OSI model. That would really buy a lot, okay? So there's a lot of resources in there to help you assimilate this information. And it's really helpful. Like if you go through that and you have a question, bring it in. Because if you have that question, other people have that question, and then we can talk about it, right? Then that, gives me the chance to be like, oh, and I can expand on that, okay? So just a little bit about mind maps, because Module 3 is really the first big mind map you had to do, right? And then Module 4. So Module 6, this one, it's a pretty important mind map. What is one of the most vulnerable layers on the whole OSI model? Layer 2. If layer 2 doesn't work, does layer 3 work? Does layer 4 work? Does layer 5, 6, 7, or 8 work? What's layer 8? Me. That's you, right? You could either be considered layer 0 or layer 8, right? It makes it real tough. So module 2 and understanding module 2 is important, right? Or module 6 because of layer 2. All right. If I need to connect a computer to a router, what kind of cable would I use? A computer to a router. A crossover. Why do I use a crossover and not a straight through? After all, they look so different. They think the same. They have similar brains. They encode information similarly. They de-encode information similarly. Okay. Routers keep track of ARP tables. Computers keep track of ARP tables. Okay. Switch to a switch. Switch to a switch. Crossover. Router to a router. Okay. Switch to a router. Okay. What if I have a T568A and a T568B? What have I got? Oh, wait. A T568A and a T568B. What do I have? I have a crossover, right? If I'm mixing the ends, I got a crossover. Okay, let's see. Here, with our data link layer, the addressing that we're talking about is MAC addressing. Okay, we're talking about MAC addressing. When we're talking about the network layer, we're talking about IP addressing. Okay? Now, when this information at layer 7, 6, and 5 get bundled up, it becomes a what? A data PDU, right? So when application, presentation, and session get packaged up, it becomes a data PDU. The next thing, if I push this down to the 4th layer, what is that process called? Encapsulation, right? Like if I move the data down and it gets wrapped up, that's called what, everybody? Encapsulation, okay, encapsulation. And now it's been encapsulated, and what do I call that PDU? Everybody. Segment. Now, at this layer, it has picked up a source and destination what? Everybody. Okay, it's picked up a source and destination port. Okay, it's the only layer that gives you a clue. The transport layer picks up source and destination port. Okay, now the segment gets pushed down to layer 3, the network layer. It gets wrapped up. What is that process called? Encapsulation. It picks up the source and destination. Okay, look. It picks up the source and destination IP address. Okay, and what is it called now? A packet. Okay, so it's in there, right? So now the packet gets pushed down and it gets wrapped up in a process called, everybody, encapsulation. Now, it picks up a source and destination MAC address, okay? Now, just something to know is the frame, right? The frame, it has no idea what's in there. It's just like it's like the Russian stacking dolls. Like all of that's just been put down, wrapped up. Okay? It's like the Russian stacking dolls. It's in there. The layer 3 IP packet is inside there. What's inside the layer 3 packet? The segment. What's inside the segment? The data. It's like the Russian stacking dolls, okay? Got that? So we're going to be breaking down this frame in a little bit here, okay? What are the two sublayers of the data link layer? There's two sublayers. Raise your hand to answer. Rob. Yes, the LLC and the MAC, okay? Which sublayer helps the network layer? The LLC, okay, the LLC. The LLC is the logical link layer, right? Okay, now do you remember when I had a picture of a router over here and I said that the router, it makes decisions, right? It's logical. It's logical. Also, another term for an IP address is called a logical address, okay? A logical address. So you can tie those terms together. You can tie those terms together. The logical link address, the LLC, logical link control. It's helping the network layer. It's helping the network layer. Okay, then we have the MAC, the media access control. What layer does it help? It helps layer 1, okay? Now, what do we have at layer 1? What's at layer 1? Hold on. It's the physical layer, but what is that called? What is that called? What's the channel called? The media. The media. The media. So, media access control. The MAC sublayer helps put the frame down onto the media access control, okay? I want you to think about, again, like how can you remember some of these things? Well, it's by putting them together with what their jobs are. The LLC helps the network layer, the logical layer. The MAC sublayer helps the media, right? Helps put the frames down on the media. All right, so let's break these layers down a little bit. Okay, the LLC, everybody, what layer does it help? LLC, what layer does it help? The network layer. Okay, the network layer. It communicates with the network layer, right? It communicates with the network layer. Now, if you recall from Module 3, the OSI model layer, that chapter, it explained some of the protocols that happen at the network layer. Give me two protocols that happen at the network layer. IP, yeah, IP happens at the network layer. So we have IP, IPv4, and IPv6. Recall? Okay. So it's going to communicate with the network layer. Now, it identifies which network layer protocol is being used. It's gonna let us know whether it's IPv4 or IPv6. Okay, think back to what I said about the packet inside the frame. The frame can't see 192.168.1.10. All it does know is if it's IPv4 or IPv6. It does need to know that, okay? It needs to know that. That's going to be important when we break down the frame. That's going to be important when we break down the frame, okay? It allows multiple layer 3 protocols. It doesn't care if it's IPv4. It doesn't care if it's IPv6. Could care less, okay? It allows them all. The LLC is the driver. It's the software part of the network interface card. It's the software part. It's not the physical part. It's again logical. It's the brain. It's the software part. It takes network protocol data, so everything that's come down, bop, 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 and it adds control information necessary to deliver the packet to the destination. Okay, because again, remember, this sublayer, its job is to help the network layer, that packet, get over to the destination. Okay? Got this part? Okay. It acts as an interface between layer 3 and layer 2. All right. Now we're going to look at the MAC sublayer. Now, what layer does the MAC sublayer help? The physical layer, right? The physical layer. It's implemented in the computer's NIC. It's the hardware piece of it. It's the physical hardware piece of it. Okay? This does the encapsulation. So the media access control sublayer, it's actually the part that's responsible for wrapping up the packet. It regulates placement of the frames onto the media. Like again, if you could imagine, it takes the frames. It's like putting them down onto the media. It's like, okay, it's like, I can see that this is light. This is fiber optic. Because now encoding has to happen once it gets onto the physical layer. So it's got to know that, okay? It has to know that it's light. It has to know if it's electricity. It communicates with wireless technologies such as Wi-Fi and Bluetooth because, again, it's media access control. And isn't Wi-Fi and Bluetooth just the media? It's just that we can't see it. Like a fiber optic cable, I can see it. An Ethernet cable, I can see it. I can't see the wireless, but it's still responsible for it. Okay? Defines media access processes performed by the hardware. So again, that's the encoding and the de-encoding. It provides the data link addressing and access to various technologies. What is the data link addressing? MAC addresses. MAC addresses. Okay. It takes a look at what the MAC address is, and then it writes it onto the RAM. It writes it onto the RAM. Now, there's a bunch of different terms that I can refer to the MAC address as. Right here, you can see that sometimes people call it a data link layer address. It's the same thing as a MAC address. What's another term for the MAC address? Hardware address. And what was the other one you just said? Physical address. MAC address, data link address, layer 2 address, hardware address, physical address, BIA, burned in address. Right? You got to know these by all these different names because you never know what term a person you're talking to will reference or use. Okay? It communicates with Ethernet to send and receive frames over the copper or the fiber optic. Remember, it's interfacing with the media, so that makes sense. It does one more thing. Can somebody tell me what that one more thing is that it does? Yes? It does error detection. Okay? It does the error detection. It happens at the MAC. Okay, can the MAC sublayer fix errors? No, it just can detect them. It can just detect them. Okay, it just detects them.
Is that due to it not having access to actually change the bits and things, or the data inside of it?
Exactly. It can't change the data inside of it. It only knows a number. Remember, it doesn't know what's inside of it. It doesn't know. It can only count the number of bytes. It's like, well, I've got 1,476 bytes. It doesn't know what the IP address is. It doesn't know if there's a PNG in there. It doesn't know if there's a JPEG in there. It doesn't know if there's, it doesn't know that. It's just like, well, I've got a job to do. I got to wrap this frame up. I got to wrap up this data. I got to move this data through, right? That's all it does. It's not smart enough, right? The switch just isn't smart enough.
Yeah, I actually brought that up when we first talked about it with like checksums and stuff like that.
Yes. It's the same thing. Yeah. Yeah. And again, there's a lot of correlation because Cisco is built on a Linux platform. Okay? Yeah. And it doesn't matter what operating system you're on, it's got to do the similar stuff. Okay? All right. The different protocols and standards that are functioning here 802.3, that's Ethernet. What else am I going to see here? 802.11 for wireless. And then there's a bunch more. I think I have 802.15 for Bluetooth. We've also got 802.16. There's a bunch of them. Okay. Driverless cars. Where do you think they function? Layer 2. Layer 2. Any car that's attached to a network, there could be some problems. Okay? So this is stuff that we need to think about as IT professionals, as networkers, as people that are doing network security, information security, cyber security. They're all related. They're all related. Okay? So the MAC sublayer controls placement of the frames onto the media. Now, again, remember we said it doesn't really matter whether it's fiber optic, whether it's radio frequencies, whether it's Ethernet. Okay, it doesn't matter. Actual media access. Let me look at that. Okay, so the media access control method is determined by the topology. Okay, so in other words, like you might have a point-to-point connection. I might have a router that's connected to another router. There's just one way in and one way out. The MAC address isn't important because it doesn't need that. It just is like, well, there's only one way to send traffic. There's only one way to receive traffic, right? So the media access control and the data link layer, it can sense the topology, okay? It can sense the topology. This is what we were looking at earlier when we were talking about our LANs and WANs. Let's see, I want to look at a couple of other things here. Okay, this is what I want to do next. Okay, I've got a handout. Pam, let's go ahead and hand out that. We're going to go over a frame. Okay, we're going to go over a frame. There are maybe 12, 13 things in this class that by the end of the class you should know. So one of them is the what? We've already talked about. Thank you, Rob. The default gateway. Okay. The other thing that's really important to know is what's something else we've gone over a lot? The OSI model. The OSI model, the PDUs, and then binary, right? When we are done with this class, you all need to know how to find a network address. And and we're going to learn VLSM. In a perfect world, you'd also be good at VLSM, but when you leave here, you should know how to find a network address. You should know the OSI model with the PDUs, the TCP/IP model, what a default gateway is, a frame. You got to know the format of a frame. Now we're going to go over the generic frame. We're not going to talk about a wireless frame or a fiber optic frame in this class. We're going to go over generically, okay? So today's the first day we're going to go over it. Add it to your list of things to know, okay? Like, I don't want to have to talk about the sections of a frame for the next 12 weeks, the next 11 weeks. I want you to come in and be able to know it after we've practiced it a few times. Okay, so we're going to fill out that whole thing together, okay? We're going to fill out the top part together, so I'm going to walk us through it. Okay, I'm going to walk us through it. So you're going to see that you've got these different sections. Now this is a frame. Generically, it's broken into 3 parts: the header, the data, and the trailer. Okay? Now remember, this is the frame, so what layer am I at? What layer am I at? Okay, everybody, what layer am I at? I'm at 2. Okay, so this is the header. Now, this says packet data. There's another word that I see this referred to, and that is the payload. Okay, the payload. Now, what will I find inside of here? What will I find inside of there? Austin? The data, everything from the upper layers, okay? What I want you to make sure you know is you're going to find everything from layer 7, 6, 5, 4, and 3 in here. Remember, it's getting encapsulated, and it's getting pushed down until we hit the frame, and that data gets wrapped up. So what's in here? Layer 7, 6, 5, 4, and 3. Does the frame know what it is? No, it doesn't know what it is. It doesn't know what it says. It doesn't know what's in there. It just knows that it's got some data, right? And its job is to move it across the what? The media. Okay, so let's talk about these things. The header is made up of 4 parts. Now really, depending upon what we're looking at, it could be made up of 30 parts. We're looking at the generic frame. Okay, we're just looking at the frame generically. Then we've got the data, also sometimes called the packet or the payload. And the reason sometimes they call it the packet is because that's just the last PDU that got wrapped up. That's the only reason, okay? And then we've got the trailer, and same goes with the trailer. We're looking at it generically. This could actually be a lot of different sections, okay? All right, so we're going to break these down. In the header, there's going to be a flag, and that is represented by bits. Remember, all of these, what the NIC card is reading is bits. Flags, this tells the frame that we're starting or we're stopping. Next, we're going to have the addressing. What kind of addressing? What kind of addressing? MAC addressing, layer 2 addressing, right? The MAC address. Now, one thing I want you to notice here is that the destination address is listed first, followed by the source address, okay? Why? Why? Why is the destination MAC address listed before the source MAC address? Raise your hand. We'll see. Hold on, Austin. So think that question through. Why might the destination address be listed before the source address? Okay. Ty. Okay. Absolutely. So that it knows where it's going. Yes. So it's going to list the destination first because it's going someplace, right? It's got to be moved to the destination. Okay. And then add to that. Do you have something to add to that? It does need to know the destination in order to be sent in the first place. Absolutely. Okay, and then I want you to just add something to that. So this is why it lists the destination first, because remember, the switch's job is to move the frame, right? It's got to move the frame. Joe.
So it may pass other things, but it needs to know when to de-encode the information.
It does need to know that. I think that goes along with it lists the destination first because it's got to know where it goes. So there's one more reason I'm looking for that adds to this. I'm going to give you a clue because I can't remember if this is in module 6 or 7. But I think it's in module 6. I'm pretty sure it's in module 6. How are frames, are there different ways to forward a frame? Are there different methods of forwarding a frame? Are there different frame forwarding methods? Yes. Does that help? Frame forward methods? No. Might be in module 7. Store and forward, cut through, that wasn't in module 6? Okay, it might be 7. It might be 7. Okay, the other reason, so I'm going to, we'll cover it when we talk about module 7. The other reason is because there's different types of frame forwarding methods. And those methods rely on the destination address, which I think you're going to read in module 7. Okay, so remember, okay, this is weird. 6 and 7 are related to each other, and 9. It's weird. 6, 7, 8 is about the networking layer. And 9 is about ARP. And ARP lives between the data link layer and the network layer. It should have been, we should have talked about ARP and then the network layer, but the book does something weird. Okay, so we got this, right? Layer 2 addressing, it lists the destination first, and the reason is because it has to go someplace. And the other reason is because of the frame forwarding methods. The type of layer 3 network protocol, okay, it needs to know what type of layer 3 protocol is it? Is it IPv4 or IPv6? Now, just to show you the simplicity of the way the bits work, if it's an IPv4, the bits look like this in the type. Because this is a what? Well, what number would this be? 4. And if it's IPv6, it would look like this because that's the number 6. So that's the way these bits are informing the frame, okay? It's easiest to show it with the type because we know IPv4 and IPv6. Okay, and then lastly is the control. The control. Now it lists QoS here, but this is also about how we control putting the frame down on the media. And what sublayer does that? The MAC. The MAC. So the type, what sublayer would the type be associated with if it's designating IPv4 or IPv6? The logical, the LLC. And this section of the control, what sublayer would it be associated with? The control, Austin. The MAC, right? It controls placement onto the media. So the type helps the LLC and the control helps the MAC. What's the data? What's the data? What, Rob? Yeah, so what's in there? Okay, the meats and the potatoes, yes, exactly right. And where's it coming from? So this data that's down here that gets wrapped up, what would I expect to see in there? Right, 3 through 7, everything from the above, everything from the upper layers, right? 76543, everything, the data represents everything that's come down from the upper layers. Then we come to the trailer where we have error detection. Okay, we have error detection. When you read module 7, think about the what I had mentioned with the layer 2 addressing the destination being first. The way that we forward the frames, that's also something that comes up with error detection. Okay? For example, if we use store and forward to move our frames, we have greater error detection. Okay? So when you read module 7, you're going to see how 6 and 7 work together. All right? It'll break down this information even more. And then lastly, okay, it's time to stop. We're going to stop the frame. Okay, that's the breakdown. So we have IPv4, IPv6. So the data contains the IP header, right? Everything from the network layer. The transport layer header, so it's going to include the source and destination what? The transport layer header will include the source and destination ports, and the application data. So anything from 7, 6, and 5. All this stuff that gets passed down. And then for our trailer, it contains control information for error detection. Okay. And such as the frame check sequence, and then just a flag to say that we're stopping. Okay. Yes.
Does the frame stop do anything like the frame start where it signals the receiving device that it's getting a message, or it's just a stop?
It's just a stop. Yeah, so that it knows when to stop, and then it does its checking. So it'll be like, okay, I'm stopping. Let me make sure I have enough bytes. Let me make sure that the frame that came over is what I was expecting. Yeah. Yes.
Does the MAC sublayer put the frame start and frame stop on there?
Does the MAC, ask me that again.
Does the MAC sublayer put the frame start
It does.
and frame stop
Yeah,
on there?
it does. Does the MAC sublayer do the frame start and the frame stop? Okay, so there's our Ethernet frame example. Okay. So I'm going to give everyone a chance to get that information in your document.
You said that the CES is the last one.
The frame check sequence, I think it's 8 bytes. I'd have to double check. I have not, so that's something that you might, like if you're going to take the CCNA, you have to memorize. I honestly, I think it's 8 bytes. That was on the attendance. It might be 4. It might be 4. Again, those are certain things that you just have to memorize, right? Yeah. This one I know is 4 bits because it's easy. 4 or 6. Yeah. Okay. Here's an easy way. Do you need me to go back? Okay. Here's how I remember this. Fat cats don't eat free. Okay. So the F is for what? Frame start. A is for addressing. T is for type. C is for, or the cats. Like, so that's why this is capitalized. F-A-T and then cats. Control, don't. Eat. Error detection, free. Frame stop. Fat cats don't eat free. Okay. Oh, here's the bytes. Here's the bytes. Let's see. Oh, and so look, I'm even wrong with the type. 2 bytes, and that's because it's going to include additional information over above just IPv4 and IPv6. Okay, frame check sequence 4 bytes. I was guessing 8, but yeah. Okay, again, notice the destination is first. When you're doing IP addressing, it's source and then destination. Okay, source and then destination. Let's see. Let me go through there. One thing I do want to point out about a wireless frame, okay? Do you remember reading about CSMA? What's CSMA? CSMA. Yeah.
It's wireless collision avoidance, right?
Exactly. So CSMA, so let's break it down. CSMA is carrier sense multi-access. That's a protocol. Okay, CSMA is a protocol. And then there's CA, collision avoidance. And that is used still today. It's more of a legacy protocol, but it's used on wireless networks because they're trying to avoid a collision. That's why sometimes if you're talking and it's, you might not hear, it's because there's a collision. There could be a collision. Now, more common because of the improvements that have been made to switches is collision detection. Collision detection. With avoidance, it's just like, well, I hope everything's okay. I'm going to go ahead and jump on the wireless and see what happens. I'm hoping I can avoid a collision. With collision detection, remember the data link layer can see the topology. So it tries to detect that there is signals on the media, that there's a frame on the media before it even puts a frame on the media. So it detects, okay? Here is one of the things that makes a wireless frame different, okay? And this is important because you'll see this a lot of times on exams, like a CCNA exam. It will show you a frame. Now, it won't tell you that it's a wireless frame. It'll just show you this picture. And it'll say, what kind of frame is this? And you're like, man, I don't know what kind of frame that is. But you know how you can tell is if you see a duration ID, that is associated with a wireless frame. Okay? A duration ID, if you see a duration ID inside the frame, what that's telling you is that is on wireless. And the reason is because of CSMA-CA, collision avoidance. The way that wireless works is it will be like, okay, hey, I need to get on the wireless media for 3 milliseconds. And so it puts the 3 milliseconds inside the frame in hopes of avoiding a collision. So the other devices will be like, okay, that frame needs to be on the media for 3 milliseconds. I'm not going to send anything for 3 milliseconds. Now, what if that frame ended up being on there for 4? There could be a collision, right? Because one device is waiting 1, 2, 3, but the other one's still on there. You have a collision. You can't hear what you're talking about. Okay? Okay. Joel, we're going to start with you. And I'm going to start because I showed the answer to this one already. All right. So the question is, where would I find the IP header? Okay. Where it contains the IP header, the transport layer protocol, PDU, and the data. Where would I find that? I would find that in the data. Okay. All right. So you get the next one. identifies IPv4 or IPv6 as the network layer protocol. Which section? The type, exactly right. Okay, Ty, you get the next one. A set of bits checked at the destination. The actual specific segment. Error detection. Okay, Nicolo, you're next. Flags to indicate the beginning of a frame. The frame start, exactly right. Joe, indicates layer 2 addressing. Addressing, exactly. Oh, was that it? I think that's it. That is, shucks is right. Okay. I just want to give you a little highlight of Module 7, and then we'll take a break, and we're going to come back and we're going to do some addressing. Okay. Module 7, remember, think of Module 7 as a build upon. It builds on everything from Module 6. So when you're doing your mind map, you should have some connections, right? Back to Module 6 or back to Module 3. It's a nice, easy way to do some connections. If you had the Linux, right? Pam brought up a really good one. You had that before. So see if there's things like that that come up. So Module 7, you're going to be learning more about MAC addresses, the MAC address table. Module 7 teaches you how the switch builds a MAC address table. Oh, switch speeds. So this is the frame forwarding mechanisms we were talking about, along with forwarding methods. These work together. You're going to review the data link sublayers. It's going to talk more about encapsulation and de-encapsulation. It's going to dig deeper into error detection. You start looking at hexadecimal again. Remember, in Module 5, we learned the basics. Why do we have to think about hexadecimal as it relates to the data link layer? Exactly, because the MAC address. So at the data link layer, the MAC address uses hexadecimal. Okay. How does a frame get processed? All right, unicast, multicast, and broadcast, auto MDIX. Make sure you watch all the videos. So this is things to think about and link them back to Module 6, okay? Link them back to Module 6. Okay. Module 1, I believe, went over unicast, and then Module 3 went over unicast, multicast, and broadcast. Yeah. Unicast, everybody, what's unicast? What's a unicast message? One device. Me and Ty are talking, unicast. Okay, what's multicast? One. Right, so I'm just talking to you, this group. What's broadcast? One to all. Now, these terms apply to a lot of different things, okay? It could be multicast on a switch, multicast on a network. Okay, there's a lot of different ways to think about unicast, multicast, and broadcast. Okay, we're going to take a break, and then when you come back, we're going to work on some addressing. It's 2:58. Be back at 2:08. Okay. We're going to talk about how to find the addresses, and I think this is the video that's due this week on Friday. We're going to go over it now a little, like just get you introduced to it. We've been talking about LANs and WANs. And if you've noticed the pictures that I showed today, most of them, we had like the default gateway. We had the router with the interface that faced the LAN. And in the pictures that we saw, most of them had more than one device, right? They'd have 3 or 4. In labs, we almost only ever just set up one device from a space perspective, right? I can't have you setting up 4 PCs a piece. But in reality, again, if you think about your home network, chances are you have more than one device on your home network. You might have a couple, okay? And as network administrators, you will need to determine those addresses. And in order to know what addresses are available, we have to figure out which addresses are available. even if you set up DHCP. So what is DHCP? Dynamic host configuration, okay? So dynamic, we statically assign IP addresses in here to make it easy. But if you're working on a larger network, you'll probably want to use DHCP because it makes it easier. Even if you're using DHCP, you have to know what addresses are available so you can tell DHCP, hey, go ahead and randomly, dynamically assign addresses from this range of addresses. Well, you, as the network administrator, are the ones who determine that. Additionally, from a security perspective, right, if you're thinking about security, there's a lot of vulnerabilities at IP. There's vulnerabilities at DHCP. DHCP distributes IP addresses, so we know there's vulnerabilities with IP. DHCP functions at the application layer. We know that there's vulnerabilities at the application layer. So again, for those of you that are moving into network security, cybersecurity, it's important that you link back, like what that is securing the network or setting up a secure network, okay? You can't have cybersecurity without knowing what a network is, how the network works, how packets move, how data moves, where your vulnerabilities are, okay? What we're gonna be doing is we're gonna take what we've learned about IP addressing and network addressing, and we're gonna keep moving on this so that we can figure out what the network address is, okay? So we're gonna walk through some examples. And we started talking about this earlier. The first thing to know is like the network address, that's when all the host bits are turned off, right? All of the host bits are turned off. And in here, do we all have the same network? We do, but our host bits are different. That's why we each have a unique IP address, because we can manipulate the host bits. Once you belong to a network, that's it. You belong to that network, okay? So a network address is when all the host bits are turned off. A first usable address, because remember, we have two addresses that aren't usable. The network address, and what's the other one? The broadcast. But we need to know what addresses I can use. What addresses can I assign to this computer and that projector and that computer? What can I use? What we're going to do is we'll figure out what the first usable address is and the last usable, and everything in between. Are those usable? Yeah, they're usable, okay? The definition of the first usable address is when all the host bits are off except the last one. All the host bits are off except the last one. Now, I believe this paper that we've given you, I think it says, let's see, network address, all host bits are off. First usable address, flip only the last bit on. So this gives you a little bit of what you're going to need to know when we work through this, okay? So the last usable is when all the host bits are on except the last one. And then if the broadcast address, what do you think the broadcast is? What would the broadcast be? Hold on. All the host bits are on. And can I use that address to assign to a PC? No. Because we reserve that address in order to send out broadcast messages. Does everybody understand that? Like it's used to broadcast, okay? It's used to broadcast. Okay. I want you to go ahead. We're going to use this one as an example, okay? So what you're going to do on your sheet is you're going to put the IP address right here. Put the IP address right there. So I'm actually going to kind of fill it out as we go. So what was it? 192.168. Let me look at it again. 1.25/24. Okay. Now, I understand that some of you are already pretty good with binary and finding the network address. Just humor me, and I'm going to have you fill out all the bits, okay? But in future ones, you won't have to. So I just want to make sure that everyone gets a nice working example by doing the bits. So on this sheet, we're just filling out the address that we're going to do together, okay? And this just breaks everything down. So if you need it as an example going forward, you've got it as an example going forward, okay? We're going to just go ahead and break down this address into these octets. So what's the first octet for that IP address? 192. And the next one. And the next one. And the next one. 25. Let's go ahead and do the subnet mask as well. So if I've got a /24, what have I got? 255, 255, 255, 0. Thank you. Okay, so now let's go ahead and I want you to bit it out. Okay, so we're going to bit out our address. 192. So at this point, you should already be able to bit these out. So if I have a /24, how many ones are turned on? 24. It's not a trick question. But I do have bad typing skills. Okay, so let's just get to this point and stop, okay? So just let's get to this point and stop. Okay, we're just going to get to this point and stop. All right, so we're here. We're going to pick up from here. So we should all have something that looks like this, right? The 192.168.1.25. This is an IP address. So if we can imagine that we've got our network, maybe we've got a couple computers, okay, and then maybe I've got another network. So we're going to fill all this in, okay, and maybe I have another network. Okay, now I can do Boolean, right? If we do Boolean, we've got a 1 and a 1, 1 and a 1, 0 and a 1, 0. We could do Boolean, or we could just mask, right? So if I look at this octet, is this part of my network? I know that because the ones are all on in my subnet mask, so it tells me this is part of my network. Do we agree? Okay, what about octet number 2? Is it part of my network? Okay, what about octet number 3? Is it part of my network? Yes. Now, all of these bits are off. So what do we know about these bits? They're off because they're what kind of bits? They're host bits, okay? Again, this is stuff that we've kind of been practicing through the weeks, okay? So I know that I've got 192.168.1.0. Now, what do you notice about the host bits? They're all off, and that was the definition of the network, when all the host bits are off, right? So here's our network bits. Here's our host bits. We got that? We're good with that? Okay, so go ahead, and you're going to fill in the network part. Yeah, so because now we've got it, we've done this part, right? So we saw what this is. We can see that this is the network part. So we're literally just giving ourselves a guide. So if you have questions in the future, you've got it worked out. Okay, so now we know that this is 192.168.1.0. So we've got that part figured out. So we know the network address. Okay, so I'm going to call this right here. This is my default gateway. So here is the network. So the network is 192.168.1.0/24. We got that? And we'll call this, again, we'll call this our pet company, Petopia. And I'm going to call this the storefront. Okay. Now let's look at the next part, the next piece of this, okay? The next piece of this is we need to find the first usable address, because we need to know what addresses can I assign to my default gateway and to my computers. And maybe I have a printer, and maybe I have a server. I might have a cash register, right? I have these different things. So we need to know what the range is. All right, we need to know what the range is. So we're going to take the network address, right? Here's our network address. And what was the definition of the first usable address with the host bits? Right. All the host bits are off except the last one. So that's what we're going to do with this next piece. The network bits stay the same. Okay, but the host bits, we leave them all off except the last one. Okay, we leave them all off except the last one. So if we take it over here to our worksheet, right? So does the first octet stay the same? It does, right? It stays the same. Now what about the second octet? Does it stay the same? It stays the same. What about the third octet? It stays the same. Okay, but what about the fourth octet? What do I need to do? I'm going to change the last bit. I'm going to turn it on. If it was off, I'm going to turn it on. Okay? And this will tell you, turn the very last host bit in the network address on. Flip only the last bit. Now I've got it bit out. I can tell what the first usable address would be. So we can fill out this part over here. 192.168.1.1. Okay. Everybody got that part? You guys are handwriting, so tell me when it's okay to move ahead. I don't want to move faster than you're moving. You good? Okay. Now we're going to do the last usable address, right? So this was our first usable. Now what was the definition of the last usable? All host bits on except the last one, okay? So we're going to come back here. We're going to start with our network address. Okay, here's our network. Here's our hosts. We're going to flip these all on except the last one. Okay, now we know 192.168.1. This one you got to add up. 128 plus 64 plus 32, blah, 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 blah. Or if you have them all turned on, that's 255 minus 1 is 254. So whichever works. So I want you to fill out your worksheet. Did I lose my worksheet? here we go. All right. Okay. So again, all of these are the same, right? For my last usable. Now, can I use my last usable? Yeah. Yeah, I can use it, right? Okay, now I know what my last usable address is. Oh, yeah. 192.168. 1 dot what? 254. Okay, so in other words, everything between the number 1 and the number 254 are usable addresses. Now, under normal rule of thumb, what would I use this 1.1 address for? Austin? Exactly right. So I'm going to come over here to my topology, and I'm going to assign this the 192.168.1.1/24. Okay? Now, what about 192.168.1.3? Is that usable? Okay, so I could assign that to my server. What about 1.27? Right? I could assign that to my printer. What about 1.5? 1.5, right? Everything between 1 and 254 is usable. And how do I arrive at that? I would just flip these bits. Like if I did this, let's make it an easy, that is an easy one. Okay, what would that address be? 88. So we can just flip these to be whatever we want them to be. 192.168, 1.224, 1100001, 1.225. So it's every combination of ones and zeros. Those are usable addresses. That's why we're all on the same network, but you have a unique address, you have a unique address, because the ones and zeros are being flipped. Okay, did we get that? Everybody? Okay, those are usable. Now, what if I had like a /28? Do I have more usable addresses or less usable addresses? Less. Remember, the bigger the subnet mask, the smaller the number of hosts you have. The smaller the subnet mask, like if I had a /16, I've got a gazillion addresses, a lot more, right? But the process of flipping the bits is exactly the same. It's exactly the same, okay? Okay, so let's go back. Now what do we have to figure out? The broadcast. Now we're going to do the broadcast. Okay, so here's this. We've got our last usable. Okay, we start with our network address. What do I do with the host bits to find the broadcast? I turn them all on. I still have network, right? Now I'm going to turn these all on, and I've got my broadcast. So I'm going to come over here, and I'm going to fill out my form. What do we know? We know this part all stays the same because I'm turning on all of the host bits. Okay. Now I've got 192.168.1.255. Okay. So I have a broadcast address, right? That if everybody needed to get a message, they would get a broadcast, and the broadcast would be, it would use 1.255 for the broadcast. Okay? This would, let me give this .45, .32, .40, .20. Okay, now I've got this part, I've got the storefront done, but over here, remember we said we had some vets? We had a vet's office, and we had some groomers. Well, they're on separate networks. The next thing I need to do is I need to figure out how do I give those their own network address, right? They need a network address. They need a network address. That's what we're going to do next, okay? That's what we're going to do next. We're going to answer these questions. How many host bits do we have if we have a /24? How many host bits, Austin? I have 8 host bits. So remember, I had a /24, right? So I've got 8 host bits, 1, 2, 3, 4, 5, 6, 7, 8, 8 host bits. That's not new, we've done that before. Now, if I have a /24, how many total addresses can I have? 256 total. So that includes my network, my broadcast, and everything in between. How many usable hosts? 254. I subtract 1 for the network, 1 for the broadcast. Okay. Now we want to figure out the next 2 networks. Okay? This is where we need to know what the positional value is. And remember, that was the magic number. If I have a /24, okay, if I have a /24, then I know that my last network bit is right here, right? So I'm just going to highlight this. I know that's my last network bit. Now, what is the positional value of that network bit? It's 1, okay? So my magic number or my increment is 1. Okay. And what octet is that 1 in? It's in the 3rd, right? It's in the 3, the 3rd octet. Okay. Now, let me go back over here. Okay, so we've gathered the information that we need. So then let's come back here. I've got my network, my first, my last, and my broadcast, right? We're all good on that. We've gathered some information that we're going to need. We know what the available addresses are. I can assign them all of these available addresses that we've talked about. Okay. Now what we need to do is find the next networks, and we're going to use the magic number to do that, okay? And this is how we do it. We know what the network address is that we started with. So we're going to take the network address that we started with. We're going to add the magic number to it in the 3rd octet, because we know that we're working in the 3rd octet. So basically, do I need to add anything to the 1st octet if my 3rd octet is where I'm doing things? Do I need to add anything to the 2nd octet? No. But my magic number was 1, so I'm going to add 1 to the 3rd octet. Was there anything in the 4th octet? No. So the next network is going to be what? 192.168.2. Okay, .2. So there is my next network. The vets, they can get 192.168.2.0/24. Okay, now I can go through the same process to find the available addresses. Okay, now I happen to know 192.168.2.1/24. That's my default gateway. Could I give this a .22? 2.22, 2.11, 2.10, okay? So the same thing, I know the network, now I can find the range. Now I need another one. I need the groomers, okay? What's the magic number? What octet am I in? 3. So do I add anything to 192? Do I add anything to 168? What do I add to the 3rd octet? I add 1 to the 3rd octet. What is my next network address? Exactly. So the groomers, their network is 192, 168.3.0/24. What address do I give to the default gateway? 3.1/24. And I can assign this one the .2, and this one the .3, and this one the .4. Okay. Could I keep going? Yes, I could keep going. I could keep going. Now, I want you to think back. Last week, we talked about how to figure out the total number of networks. Do you remember how we did that? So we know how to find the number of addresses. If I have a /24, how many networks could I have? How do I do the math? We did that last. How many network bits are in the last octet, right? Okay, so if I go back here and I look at this, okay, so this is my last octet with network bits, right? And are these all network bits? Okay, so what do I do? 2 to the power of 8, which equals 256. So if you come back here, imagine, right, when we're doing the networks, so I've got the .3. Could I do add 001 to get a .4? And then 001 to get a .5, .6, .7, .8, .9, .128, .129, .130, .254. I can get 256 networks with a /24. Okay? No, the 0. So we started with 1, but I could get 192.168.0.0. Yeah, we just started with the 1. Okay? That's how we get different networks. Okay? That's how we get different networks. Now, this is called equal subnetting. This is called equal subnetting. Okay? Because all of the subnetworks, this is a subnetwork, a subnetwork, a subnetwork, they're all exactly the same size. That's called equal subnetting, equal subnetworks. Now we're going to learn how to do variable length subnetting. Because what if I only have 3 groomers, I've got 1 vet, and I've got the store? I'd kind of be wasting a bunch of addresses. Okay? I'd be wasting a bunch of addresses. So this is called equal subnetting. Okay, I'm going to give you an address, and you're going to add this address to another blank. Do you have a blank on the back? Okay. You don't have a blank on the back? Okay. Do we have? Here, you can have this one. A blank one. Okay. So let's do this one. Let's see. Let's do 168.160.245/28. Okay. /28. So write that down. That's the one you're going to take and you're going to do as homework. And then I've got one more thing to send you home with. If I can find it. Okay. Does everybody know where to find the important objectives? Yes, no? Okay. So the important objectives are in this first module, or you can find them in the learning resources. Okay. So they are right here, important objectives. And they're by module, so module 6. They're a list of questions. Okay, I'm going to assign you each a question. 2 questions, at least 2 questions. I'm going to assign you each 2 questions. And you're going to use those questions for this assignment, okay? So you're going to help to create a study guide. So here's an example. Okay, so you're going to be assigned one of the important objectives. So you'll add the question, and then you're going to answer the question. So here's an example. So I was assigned question number 5. What is the difference between CSMA CD and CSMA CA? And in what media are they used? So I started answering this question. Okay, I'm going to finish it. I'm going to add a little bit more. What is the difference between CSMA CD and CA? I've also included a little picture. And then I started writing. CSMA is a protocol that helps to avoid collisions between frames and packets. There are 2 types of collision detection, 2 types. Collision detection, which is older. Here the frame has to try and detect when other frames are on the media or the channel and hope that it doesn't use the media at the same time. CD is still applicable to collision detection is still applicable. I can't even understand my own writing. Wireless networks. Collision avoidance is newer, blah, blah, blah. So does that sound like me talking, like my own words, or does it sound like AI? It does not sound like AI. That is me talking.
It sounds really formulated.
I know a lot about CSMA. Okay? I don't think that it would say, here the frame has to try and detect. I don't know. The point is, it needs to come from you. If it looks like AI, I'm going to give you a 0. Okay? Then you can have a one-on-one meeting with me and convince me of it. I'm not saying dumb down your wording. I can tell the difference, okay? I can tell the difference. Or I'll ask you. I'll just say, hey, this looks like it. Let's have a conversation. Okay. I'm going to assign you, so we're going to count off. Can you start for me, Gianni? 1, 5. I'm number 5. Okay, so that's the number that you have. Okay, let me see how many questions I have. 13. Okay. So then I'm going to come back 14. Rob, you also have 15, 16, 17, 18, 19, 20, 21. 1, 2, 3, 4. I will add 4 more questions before 5 o'clock. I will add 4 more questions before 5 o'clock. So you have what number? So you're going to have 22, which I'm going to add. You're going to have 23, you're going to have 24, and you're going to have 25, okay? So I'll have those questions added before. Now, listen, there might be some overlap. Your question might be similar to another question. That's okay. This is a study guide. And why might you need a study guide? And maybe we'll have a proficiency assessment in a week or 2 that you might be able to use this on. Okay? So, when you're answering, think about how would I explain this to a 10th grader? Right? How would I explain this to someone who's interested in IT? Okay? All right, so you have 2 homework assignments. You're answering 2 questions, okay? And then you're doing the problem that I gave you, 192.168.160.245/28. If you need help, you're more than welcome to stay here and we can help you with that. Okay. I will send out a reminder about the Padlet. Make sure you get that done before you come to class on Wednesday. It's called That's what this is. Sorry, yeah. That's what this guy is. No, you're going to do it in the Padlet. So you will be assigned several important objectives, which is 2. Your task is to contribute to a collaborative study guide by thoroughly answering the important objective question that you've been assigned. Share your insights based on what you've learned and feel free to include pictures, videos, or articles. Okay, so here's the full directions, right? Because then you're also going to be commenting on people's and sending me information so I know that you did it, okay? Questions? Everybody good? Okay. Have a good one. I won't do anything harder than what these are. Yeah.
Right here.
Mhm.
And then the increment in the fourth octet.
Yes.
So with this one being 240,
Mhm.
to carry over, correct?
Oh crap!
I just wanted to make sure because I was like, that's really complicated for the new one. So I was like, ooh, I'm already doing that.
Oh, I wasn't thinking.
I'm sorry. I meant to bring it up earlier. I was like, ooh, that's a little hard, right? So yeah. Maybe they'll get it.
Okay, hey everybody, I gave you a really hard one accidentally. Instead of 245, 127. No, how about 65? 65. I gave you a really hard one. Make it 65. I'm so sorry. I gave you a really hard one. But I wasn't thinking. My advanced brain was not thinking. 160, 65, 28. Okay, do 65 because I'm so sorry. Look, you can try the hard. Did you get it?
I was working on the second one.
Do you know how to do it?
I'll figure it out.
Okay. Do you want me to? I'm going to tell you how. It's like a dollar bill. If you have 99 cents and I give you one more penny, do you have 100 cents or do you have $1? Well, would we call it 100 cents or would we say, oh, $1? I have $1. What did we do? We carried the one over. So when you go above 255, you have to carry the one over and zero out the last octet. So this is going to become 161 and that's going to be 0.
The next one would be,
Yeah, so
says original is right. So this one would be 0.
nope. So this one's right. It's not a 24. It's 28. Okay. So when you add 16 to 240, you have 256. There's no such number. So you're going to take the 1 and you carry it over and you make this 161 and you zero out the last octet. So this would be 192.168.161.0/28. Then you're starting over.
161.17.
Right. It would be 161.0. The next one would be 161.16. The third one. The third one. I'm sorry. Darn it, Ty. Thank you for bringing that to my attention.
So for the objective study guide, how many sentences do you want us to?
You need to thoroughly answer the question. So if you can do that in one sentence, which I doubt, it needs to be a thorough answer. I'm not going to decide how many sentences. Yes, it does. Yes, it does. Does it? You can do the other one too. It's just that it's a really hard one. You do either one. Do either one, but it's a hard one. Joe couldn't figure it out initially, right? But then got it. It's hard.
I would have looked it up.
Yeah, for sure. For sure. Yeah. No, and that's really what you would have to do. So, but this is an easier one, the 65. So,
Well, I guess I'm prompted to hard mode then.
yes.
I'm not
Do you want another one? No. Okay. So you just carry the, so whenever you have, so there's really no such number as 256, right? So if your network is 240, okay? If you add 16 to it, that makes it 256, but there's no such number. So what you do is you take that 1 and you put it in the third octet. So it goes from 160 to 161, and then you zero out the fourth octet and it starts over. Yes, exactly. Well, and the example I usually use is kind of like with pennies. If you have 99 pennies, we call that 99 cents, right? If I give you one more penny, do you ever hear someone say, I have 100 cents? Or do you say, oh, I have $1, right? Well, what did you do? What we did is we added that penny, we carry the 1 over and zero out the rest. So it's $1. That's what we do with this. If it hits 256, like 255, we're still good. You add one more bit and you're like, whoa. So you carry that into the octet right in front of it and you zero out the other octet. Yes, exactly. Exactly.